is PhD Denis Galaktionov with presentation Anodic nanostructuring in titanium cycles.
Okay, thanks. Hello, dear colleagues. I want to present you my work on the structure of titanium oxide. I did this work for research that have a part of contact sport project about developing nanomaterials. Here are some motivation leads. There is some comparing with aluminum oxide or titanium oxide. It's more electroactivity and long life surface and etching by chloride ions. It's some scheme of how we created our titanium oxide film and etching our nano channels. It's magnetron sputtering etching and magnetron sputtering and on our experiment, films are formed in two stages. In the first stage is magnetron sputtering. The essential peculiarity of the process is anodic oxidation titanium arising technical mechanical stress. And we can see that our film can have acceleration at because of this mechanical stresses and follow the adhesion to surface. Discharging of these stresses can go on in two ways. In that way, and if we can do some higher elevation, we can see some nanostructured dots on the surface. During anodic oxidation, the film of titanium on the basic part corresponds the formation of solution to electric field, and in point of fact it is process junction of capacitor. One of capacitor plates is the film of titanium and other is electrolyte which adjacent to film of titanium oxide. If electrode contains no fluid ions, then process oxidation stops here. If the process contains some amount of fluid ions, then channel irritation begins and the curve has typical form ABC. Channels etching takes place on the part B. On the part C, channels irritation and forming a separately stained pillars or sponges material formation take place. A lot of factors have an effect on this curve form. There is concentration of fluid ions, electrolyte temperature, substrate material, and other factors. Our approach is so that estimate points ABC with every factor combination. There are some started on the next, you can see morphology of evaporated by magnetron sputtering titanium. There are nanocrystallites or other formation on the surface. On the next slide, the data of atomic force microscopy is presented. There are three junction points of the surface morphology and showing their position on the curve. Near the point A, the curve relief accounts about 5 nanometers. Here. As the branching channels begins to the next picture, relief accounts about 30 nanometers and to high to the 100 nanometers. Research on the scanning electron microscopy discovers representative points allows us to understand that in relative formation, the nanostructure and their subsequent interaction is going on. This is some efficiency analysis at of these pictures. It's FM pictures of surface in 2.1 and 2. The image, there is some typical spacing of veils. In our experiment sites, the veils are typical with tens of nanometers. The evaluation of the geometrical structure of the channels which are formed in the film is essential. On this image is the result of observation on the texture bar in the substrate with the film nanostructure standing inside presented. We can see separate channels and it is said that the depth of the wells about 300 nanometers, while the thickness of the whole film is 700 nanometers. The depth of the channel is typical quality. It has small statistical structure. The more detailed research we managed in Lviv University. On this sample, the heating at the angle 3 degrees with the help of ions argon beam, which fits making precision slice that was carried out. We observed this structure at the angle 50 degrees. There is typical spacing of the structure about 60 nanometers. On the foreground, we can see the ordered circles of the channels, which we can describe by correlated position of channels. The same was inside on two-dimensional Fourier transform. We can see typical degree present. This representation shows that correlation lengths confirm both sides and mutual position of the channels, and it's 1 and 1.6 micrometers. Next slide. Yeah, there are some conclusions, and we hope we can somehow use it for biosensors. Okay, thanks.
Thank you very much for your paper. Any question?
What can you say about the conditions of anodic oxidation of titanium?
We have some surface of with glass, and it's the surface for heating for create more
What is electrolyte?
It's electrolyte with fluoride.
My question is, what recommendations would you propose to obtain the most available titanium oxide film without any significant mechanical stress?
Without no, maybe without
Significant.
Sorry.
With minimal mechanical stress.
We mechanical stress create this nano structural forms. Without this, we can't do this nanostructural dots.
Your recommendations?
My recommendation is heating your surface.
Thank you very much.